Welcome everyone. Today our topic is Dijkstra algorithm to find the shortest path between two vertices of a graph. So basically by using this Dijkstra's algorithm, we can find the shortest distance between any two vertices of a non-directed graph and also for a directed graph. So before starting that, we will actually learn one types of graph which is called the weighted graph, and we will find the shortest path for this type of weighted graph. So what is weighted graph? So weighted graph means a graph in which every edges are assigned or associated with some real values. So that means just take this graph, and if you see here, the vertices are v1, v2, v3, v4 and v5, and you can see that there are no values in these edges, so that's why this is not a weighted graph. But if we place some real values and with respect to every of these edges in this way, suppose this is 2, this is 5 unit, this is 7, this is 2 unit, and this is suppose 8 unit, so or maybe 8.2 also, these are real values. So if we assign some real values with each edge of a graph G, and then we call this G graph is a weighted graph. So weighted graph means, so if a real number is associated with um, each edge of a graph G, and then G is called a weighted graph. Now this graph may be also a directed graph. That means you can give some weights in the directed graph also in this type of directed graph. So this is also one weighted graph. Now in this type of weighted graph, so just I am again removing these values. Okay, so oh, problems here we are getting. This is not a edge direction. Now we find the shortest path. Another term is shortest path. Now suppose if you take this graph and if we connect these two values also, and this is suppose with 7 unit. Now if you want to go from this v1 to v4, suppose you want to go from v1 to v4, then you can see that you have many paths to go from v1 to v4. That means you can choose this way, that you can directly go from v1 to v4, or you can choose this, that from v1 to then v2, from this v2 to v5, and after that from that v5 to v4, you can choose that. Also one can choose from v1 to v3 and from v3 to then v4 also. So there are many paths available to go from one vertex to another vertex, and in between these paths, which is of the minimum weight, it is called the shortest path. And basically Dijkstra algorithm is an algorithm by using which you can find the shortest path and the distance of this shortest path. That means the weight of the shortest path, which is called the shortest distance. So that means if vi and vj be two vertices of this graph, then there may exist several paths. So there may exist several paths several paths and connecting this Vi and Vj, connecting suppose Vi and Vj, and among those the path containing the minimum weight, the path containing the minimum weight is called the shortest path. Is called the shortest path from Vi to Vj. Okay. So now the Dijkstra's algorithm. So we will discuss the Dijkstra algorithm by which you can find the shortest distance. So there are the algorithm. This is a algorithm. So that's why there are some steps to determine the shortest path and shortest distance. So before directly doing the table, we will actually see some of the steps of this Dijkstra algorithm by using one of the example. After that, we comes to the theorem portion. So first take one of the problem. So your problem may looks like this, and I will say what you have to do or how you can start. So this is the problem question, that apply Dijkstra's algorithm. Apply Dijkstra's algorithm to find the shortest path. The shortest path and shortest distance. And the shortest distance. Okay. And this is the graph. Okay. Suppose this is the first edge, and then take another edge here, another edge is here, then connect these two edge, these two, and take one loops here. Take it as A, this as B, suppose this is C, and this as suppose D, this is E, and suppose this is F, and this is 3 unit, this is 4 unit, 2 unit, this is 2.3 unit, 2.3, this is 6 unit, this is 2.7 unit, 1.5 unit, this is 3 unit, and it is 3.3, and it is 2.3, and it is 1 unit loop sizes. So these are the weight and associated with the edges. Now you have to find the shortest path from, so path and shortest distance from A to F. So from what? From A to F. And starting from A, and you have to go to F, and A to F you have to find the shortest distance. Okay. So first of all, from where we start, so first what you have to do, so first of all, if there is any self loop, so step one, this is, you can take it as step one, that discard all self loop, discard all self loops. Because if there is any self loop, and if you go on this into these self loops, then it will only increase the traverse distance of your path, but you are again at the same point. You start from the point D, and again you at the point D. So to find the shortest path, you will never use this type of self loop. So that's why first at the starting we will discard this type of self loop. And this algorithm is for the non-directed graph. Here first we taking for the non-directed graph, and after that in another lecture we will discuss it for the, we will discuss for the directed graph. Then step two, the thing, So if there is any parallel edges, if this graph G, if this graph G has parallel edges. So first of all, discard this, and second of all, you can see that from A to C there are two parallel edges. One is 3 unit, another is 4 unit. So we will take the minimum weight edge and we will discard the longer edges. So here 4 is the longer edge, so we discard this 4 and we will only take the 3. So if G has parallel edges between two vertices, and then all discard all except that having least weight, that having least weight. That means if there are one more, another, suppose 7, so we will discard all these lines. We will only take this minimum weighted lines, and which is this 3. So this is the second step. And at the after doing these two steps, we will again draw this graph to start the Dijkstra algorithms. So after discarding or the self loop and longer parallel edges, and the longer parallel edges uh, we get. Now we get the actual graph in this way. So now we draw the graph again, and this is the graph. Now we will draw the graph in a broad way, because we have to do some computations in the graph, and we have to make some table. So that's why. So this is the first structure. We are not actually drawing these parallel edges, and from this E to that F, take one edge, and there is another edge, there is one, and there is another edges, I think, in this way. And also we will omit this self loop here. So we will not giving this line and this line. So these two lines we have removed. So that means we don't have these two lines. And this is the new graph now. A, this is B, this is C, and this is D, this is E, and this is F. Now we have to start from A and we have to go up to F. So now the new thing is, so we have to go from A to F. This is our target. So A is our initial vertex. A is our initial vertex, and this F is our terminating vertex or the destination vertex. This is the destination vertex. So we start the algorithm from A and we stop the algorithm whenever we reach the point F. This is the process. So at the start, set 0 label. Okay, set 0 as the permanent level to the vertex. Set 0 at the initial vertex. At the initial vertex, and infinity to every other vertex, other vertices. This is very much important. So at the starting, so we will start from A. That means this A is our starting point. A is our starting point, and at the starting we will set that 0 at the point A, and for the every other point we will set infinity, 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 and infinity in the every other vertices. Okay. This is the first line that we set 0 at the point A and infinity at the every other vertices. And we draw a table here. So tables looks like that. So first Draw some rows and make some boxes here like this, and for each vertices we need some boxes. So it is A, it is B, C, D, E, F, and this for the remarks. This for the remarks. You need one. And whenever you start your process, so we start from A. So put 0 at A and infinity at every other vertices. It is the initiation of the algorithm. So after that, mark this A by box because A is already selected, and we mark it with a tick. And A is over, so we don't take this A anymore. Now we start our travel from the point A and we go from A to any other vertices. We go from A to any other vertices. That means A to B, A to C, A to E, A to D, and A to F. We try to go from A to any other vertices. And in this travel, if there is direct edge with weight, in this way, in the previous graph, we have weight here 2, here 3, here the weight is 2.3, here the weight is 2.7, and here the weight is 6, here again 3, here 3.3, here 2.3, and here 1.5. Okay, so these are the weights. So now this is the most important thing here. Whenever you go from A to B, it will be of weight 2 unit. From A to C, it will be of weight 3 unit. But whenever you go from A to E, so there is no direct path. That means we will take this weight as infinity. Okay. So this is one of the most important thing, and we are writing this here. So we will take the weight between Vi Vj, between Vi comma Vj as Wij, suppose weight between Vi and Vj as infinity. So we will take the weight between Vi and Vj as infinity when there is no edge between Vi and Vj, between Vi and Vj. So this is very much important, very much. So if there is no edge between Vi and Vj directly, so then we take the weight as infinity. So we will take the weight between Vi and Vj. Suppose here, so from A to C the weight is 3, from A to B the weight is 2, but from A to E there is no edge. That's why we take this distance as infinity. So you can travel from A to E. You can travel by this path A, B, E, but here we don't actually we are not taking the path. We are going from A to the next vertex, not from B to E. We will come it after step by step. So now from A to any other vertex. So A to B, this is 2, A to C, this is 3. From A to E, this is what? No direct edge, so it is infinity. A to F, no direct edge, it is infinity. And A to D, there also no direct edge, so we take it infinity. So in the next step, we will update these values and accept this A, because we start from the A and we will calculate the traverse distance now. So from A to B, it will take, so it is 0 at the previous stage. Now you have to travel 2 units, so it is 0 plus 2. So whenever you come from A to B, you have to traverse 0 plus this 2 distance. Now from here, this is 0 plus what? 3 unit. So 0 units, that means it is the initial stage, and after that whenever you reach C, you will travel this plus 3 unit distance. And from A to E, it will be 0 plus infinity. From A to F, this will be 0 plus infinity, and A to D also 0 plus infinity. So now put these values here, 0 plus infinity values. So after doing that step, you have to take the minimum value of these two values. You have to take that, the minimum values of these two variables. This is the next step, that you will find the minimum value of these two variables, the minimum value of these two variables, the minimum value, and here also the minimum values of these two variables. This is the next step. So in the next step, we will take the minimum values of these updated values. So the previous assigned value is infinity, and the new assigned values are 0 to 2, 0 plus 3, 0 plus infinity, these green values. After that, we will take the minimum of these minimum values in the next step. So that's why we are taking one duplication of this page. Now in this duplicate page, we don't require these values because it is already in our previous page, but this is very much important because every time we use this rule, if there is no direct edge, then obviously we will take the distance as infinity. So now from the previous page, you can see that we have to take the minimum value of these variables. Now we are filling the table here. So now just use the table. Okay, so we are doing ready of this whole table because we need it multiple times in multiple pages. So that's why just draw it and draw this remarks. After that, we will need some of the rows 1, 2, 3, and 4. So if required, we will make some more rows here if required. But for now, I think it is okay. There are total 1, 2, 3, 4, 5 number of rows. We can start it now. So at the first here, we will write that the minimum value of the previous level, it is infinity, comma. So this is the way of writing infinity, comma, and minimum of again the previous value infinity, comma. So minimum value of the previous value infinity, comma, minimum of the previous value infinity, comma, minimum of the previous value infinity, comma. And then what we do? Then we take the again the previous weight plus the previous weight plus the previous weight, permanent level weight, previous weight plus, and previous weight plus. And then we go to the every other vertex. That means here you can see that we have set this 0 plus 2, this has 0 plus 3, this has 0 plus infinity, it is 0 plus infinity, and then we take this value. So for the B it will be 0 plus 2, for the C it will be 0 plus 3, for the D it will be 0 plus infinity, for the E it will be 0 plus infinity, and for the F it will be also the 0 plus infinity. After that, we will take the minimum value of this. And what is the minimum value? Here the minimum value is 2. Here the minimum value is 3. Here the minimum value is infinity. Here also infinity, and here also infinity. Okay. So after that, we will fix this. We will take the minimum of these minimum values, and we will mark that value with box, and give a tick here. And we say that B is labeled as permanent vertex. So this is the new permanent vertex. So B is now labeled as the permanent vertex. So after that, we do it in the same way. That means in the next page, we will take the minimum values of this, because the previous page these are the values, but here we will take the minimum values here. So just 1 minute. So we are updating these values here. So this value is 2. Now new updated values. This value is 2. This value is 3. This value is infinity. This updated value is infinity, and this updated value is also infinity. Now we are going to the next move. So This is the next move. Or so now we have set 2 as the permanent vertex. This is mark, and that means this B as the permanent vertex. Now we start from this B and we go to every other vertices which are not already set as a permanent vertex. So we are not going to A again because this is already set to be a permanent vertex. So now we go from B to C, E, D and F. So to do that we do the same things. So whenever you go from this B to the other values, so suppose from B to C, so it will be previously 2 unit and you will travel 2 plus 2.3. From B to E, it will be 2 plus, now you will travel 2.7. So it will 2 plus 2.7, and now it will be 2 plus, no direct edge infinity distance, and here also 2 plus, no direct edge infinity distance. And after that again we do the same thing here. So we take the minimum value of these two, we take the minimum value of these two, and again we take the minimum value of these two and minimum of these two values. Okay. So these are the next step. So here we are taking this. So whenever this A and B are completed, so you can fill these boxes with the same values 0 0 0 and 2 2 2, so that you never again use these values, and we will always take the minimum from this minimum mark values, minimum of minimum. So now we go from B to C. So again the same things you have to do. That means the minimum of the previous level 3 comma, the minimum of the previous level infinity comma, minimum of the previous level infinity comma, and minimum of the previous level infinity comma. And here the previous traverse distance 2 plus 2 plus 2 plus and 2 plus. Now we add the new distances here. So from B to C it is 2 plus 2.3, and from B to D it is infinity, from B to E it is 2.7, 2 point this is 7, from B to F this is infinity. So the minimum value is here 3, here the minimum value is infinity, here it is 4.7, and here it is also infinity. Now again check the minimum of this minimum values, and it is 3, and this 3 corresponding to C. So now we are updating this with the minimum value. So here the minimum value is 3, here the minimum value is infinity, and here the minimum value is 4.7, and here the minimum value is infinity. So now with this minimum value, C is set to be your next permanent vertex. So C is now the next permanent vertex. So we set the C as the permanent vertex in this step, and we write here that C is labeled as permanent vertex. Okay. And then fill the other values with 3 and 3, same values. After that you have to do the same thing, and again from this C, and from this C you have to go to the any other points. So that's why, and do the same things here. So here we will start from the point C, and we do the same things in the boxes. So minimum of, we do it again. So minimum of the previous assigned value infinity, minimum of the previous assigned value 4.7 comma, and minimum of the previous assigned value infinity comma. And then we start from the 3, so it is 3 plus, it is 3 plus, it is 3 plus. Then we add the values. So that means from C to E, if you go, so it will be 4.7 plus 6, it is updated with. So not 4.7, it is 3 here, and then 3 plus 6. Previously it is 3, and now we add 6 here because there is a distance of 6 units. From C to D, it will be 3 plus 1.5, and from C to F, no direct edge, so this is 3 plus infinity. And after that again the same thing, we will take the minimum value of these variables, minimum here the minimum values of this, and here also the minimum value of this variables. And after that just set it. So from C to D it is 1.5. So C to D it is 3 plus 1.5. From C to E it is 3 plus 6, and from C to F there is no direct distance, so it is infinity. So that's why now your minimum value is 4.5 here. Here the minimum value is 4.7, and here the minimum value is infinity, and this is the minimum of the minimum value, so we mark it here. So this D is the minimum values. So that's why now we are at D. We are at D, so we are updating these values. So this minimum value is 4.5. This minimum value is 4.7. This is the 4.7 minimum value. Here the minimum value is now again infinity. Okay. So after that, this D is said to be as the permanent vertex. So D is over. So D is the next permanent vertex. So D is labeled as permanent vertex. Okay. So then again you have to do this. So it is over, so you can fill it by 4.5. After that we go from this D vertex to E and F. So to do that we will go to the next page. I will set it again. So just one duplicate page here. So in your exams you don't have to create all these tables multiple times. You will do it in one table, because we don't need this graph changes. We only need this table, but to better understood this we are actually creating multiple pages, and one step by step in every page. So that's why here we will start from this D and we will update the other values. So the update is from D to E there is 3 unit distance. So it will be 4.5 unit plus 3 unit, and from here this is 4.5 and plus 2.3 unit distance. And after that you will take the minimum of this calculation. So minimum of this calculation, and here also the minimum of this calculation will calculate. So we are updating this as in the previous problems. So here this is minimum of the previous value 4.7 comma, and minimum of the previous value infinity comma. We start with 4.5 plus 4.5 plus. So from D to E this distance is a 3 unit distance, and here a 2.3 unit distance. So it is a 3 unit distance and it is a 2.3 unit distance. So here the minimum value is 4.7 and 7.5. So it is 4.7, and here the minimum distance is a 6.8. This is the minimum distance. Now if you take the minimum of the minimum, so it will be 4.7, this value. Now just mark it, and this is corresponding to, I think, line E. So E is labeled as the permanent vertex. E is labeled as the permanent vertex. Permanent vertex. So now we do it in the graph also, and just we changes the values. So here the minimum value of the 4.5 plus 3 and 4.7, minimum value is 4.7, and here the minimum value is 6.8. Now this is our new edge, is our new permanent vertex. So after that we take a box on it, and now we have only one step to go from E to the destination vertex F. So we do it in the next and the final graphs. So this is the final step. So here we need one more table line. So this is another table line to go to the permanent vertex. Just fill the values with the previous values, 3, and here with the 4.5. And after that it is 4.7, so also mark it as 4.7, and here this is 6.8. So 6.8, then again we do that. So minimum of the previous value, this is 6.8 and comma, and we start from this 4.7 plus. So 4.7 plus what? Here From E to F, distance is 3.3 unit. So we will take 3.3 here and we will take the sum. So it will be some 8.1 or 8 distance. So 8 and 6.8, minimum is again 6.8. So this is the destination vertex corresponding to F. So F is the destination vertex. Destination vertex. Okay. So the table is over. So that means now you can see the table. So here this is 6.8, and with this 6.8 we also take so the previous level is 6.8, 6.8, and the new level is the 4.7 and plus 4.7 and plus what 3.3, and then the minimum of these two values, and this minimum of these two value is 6.8. So this 6.8 is the last destination vertex. Now that means not this is marked, so this E is marked and this F is marked with 6.8 as permanent vertex. So we are also changing this in the subsequent pages because this notation is not given correctly. So here D is marked, not that. So this E is marked with the value, and here also is this type of edges. Okay. So now it is the last table, and from this table, this is our observation that from A to C the distance is 3 unit, shortest distance. From A to B shortest distance is 2 unit. From A to E shortest distance is 4.7. From A to D shortest distance 4.5, and from A to F shortest distance is 6.8. So this is the shortest distance from A to the any other vertices. Now we will find the shortest distance and shortest path from this table. So the shortest distance from A to B, this is 2 unit, you can see here. The shortest distance from A to C, this is the level 3 unit. From the shortest distance from A to D, this is the level 4.5. Shortest distance from A to the E, this is 4.7, and the shortest distance from A to F, this line, this is 6.8. So these are the shortest distance, and which you can read from this table. So the shortest, so the path, and so from A to F, A to B, shortest distance is what? Shortest distance 2 unit. From A to C, the shortest distance is 3 unit. From A to D, the shortest distance is 4.5 unit. A to E, shortest distance is 4.7 unit, and A to F, the shortest distance is 6.8 unit. So from the graph, you can observe this shortest distance from one starting initial point to the every other vertices. But also that means for our question, the shortest distance from A to F is 6.8. So we have one answer. Now we need the path to determine. So for the path, there is one rule. The rule is always start with the destination vertex from where you have to go. So that means suppose we need the path from A to F. So the shortest path from A to F, we need this path. So we always start from the F, that means the destination vertex. So just start from the F and go in the upward direction until you have got one changes in the values. So we will go in the upward direction, and you can see it is 6.8, it is also 6.8, and it is infinity. So here we got one changes in the values. So start from the destination vertex and go in the upward directions, and until you will get one changes in the values. So whenever you get one changes, now go horizontally and to that row, go horizontally and throughout this row to find a box. Okay, So now we go horizontally to find a box, and here we got one box. And whenever you get one box, now just stop here and again go in the upward direction, and again go in the upward direction until you get one changes. So here we go in the upward direction, and here you can see that there is one changes in the value 4.5 to infinity. So that means again we go throughout this row to find one box. So this is the next box what we have got. Then again go in the upward directions to find another changes. So here it is also 3, here it is infinity. So again we got the changes. Now we go in the horizontal direction to find another boxes. Okay, so this is the path what we have got. So that means from A, then we go to the C, then we go to the D, and then we go to the F, and this is the shortest path from A to the F. So A to C, C to D, and D to F. Shortest path is A to C, then what? C to D, and after that D to F. So this is the shortest path, and you can see it from the graph. So A to C, C to D, and D to F. That means this road A to C, then C to D, and then this D to F. So you can see this. So this is 3, and this is 2.3 and 1.5. So this two, actually this is 6.8. So this is the shortest path from this to that value. Okay, and similarly you can do it for the every other also. So if you want to know the shortest path from this A to E, so in that case you will start your travel from the point E here. So you will start your travel from here, and you will go in the upside direction and until you got one changes. So this is 4.7, 4.7, again this is 4.7, and here you have got one changes infinity. Now go in the horizontal direction to find one boxes. So here one box occur, after that go in the upside direction, and here one changes occur, and then go to 0. So this is the path. So here from A to B and then B to E, this is the shortest path. So the here the shortest path is A to B and B to E. Okay, similarly the shortest path and from A to D, if you want to get that, so you will start your travel from the point D. So now just take another. So you will start your travel from D, and you will go in the upward direction to find the changes. So just go here, and there is the changes, path changes. After that go in the horizontal direction to find a boxes. So this is the box, and after that go in the upward directions to find the changes. Here the changes, and then just go to the point. So this is the value. So from A to C and then C to D, and this is the value. So that means from A to C and then C to D. So this is the shortest distance. And similarly for C and D, it is very easier. So for C, it is direct path A to C, because you can see that from A to C, and for B it is a direct path A to B. So that's why this is the process how you can determine the table. But for the from the next time, actually we will directly calculate this table. So not this step by step method. We will take one problem and we will directly calculate this table. Okay, so just take one exercise or homework, and uh, just try it. So we will discuss it in the starting of our next class, and after that we will start the directed graph for this Dijkstra algorithm for the directed graph. So just take one homework, HW problem. So it is also from the Dijkstra algorithms. So just take it. So apply Dijkstra's algorithm. Apply Dijkstra's algorithm to find the shortest distance and shortest path of this graph. So this is the graph take it, and here this is the graph. Take one loops here, and these are the values A, B, C, D, E, and it is F. Unit is 4 unit, one, this is 2 unit, this is 1 unit, this is 5 unit, and take a join here, this is 8 unit, 10 unit, this 12 unit, 2 unit, this is 6 unit, and this is 3 unit, and this is 4 unit. And from A to path of that graph, and from A to F. Okay, so from A to F, find the shortest distance for that problem. I think every edges have some weights. Okay, so just try it and try to find it by forming the Dijkstra algorithm. First erase these parallel edges with 12 weight and erase these loops, and then whatever you get, find the Dijkstra's algorithm by using one single table. We don't need this multiple graphs. So just do it in the table. Whatever you want to do, just do it in the table, not in the graph. Okay, and just form one this type of table and from the graph. Okay, just try, and we will discuss it in our next class. So that's the end of our lecture, and we will continue this by discussing the homework problem, and after that we will start the Dijkstra's algorithm for the directed graph. So thank you all for watching.